Welcome to our project presentation for BDA 20603 by Group 12. The title of our project is Application of Archimedes Principle using an Arduino-based strain gauge prototype. In this experiment, we have developed a digital density analyzer that applies strain gauge technology to verify Archimedes principle. Before we begin the demonstration, it is important to keep in mind that the values displayed on the digital module is the raw sensor data from the load cell. Calibration factor is applied later to calculate the density. You will see these raw values change in real time, which show that our prototype is very sensitive to the buoyant force. We begin our validation process with a low density solid, standard rubber eraser. First, suspend the eraser in the air to get the baseline mass reading. Notice the raw data start to stabilize on the display. Now, submerge the eraser in pure water. The upward force reduces the apparent weight measured by the strain gauge. Even for a light object like this, our prototype successfully detects the displacement. Next, we test a high-density material using a steel bowl. We record the initial raw data in the air. This value will be the reference for the object true mass. Because steel is obviously denser than the rubber we just tested, the weight loss after submerging in water is lesser. For our final and most comprehensive experiment, we've used a stone as a control mass to analyze the density of 3 different fluids. First, we obtain the reading of the stone in air. Second, we submerge the stone in water. This gives reference for fluid density. Third, transfer the stone into a salt water solution. Please observe the reading on the display. Salt water is less denser than water, which creates a strong buoyant force. The strain gauge detects the increase in buoyant force, therefore resulting in a lower weight reading. Finally, we test the stone in cooking oil. Since oil is less denser than water, it provides less upthrust. The raw data prove that our prototype can effectively differentiate between fluid densities in a real-world setting. The comparative data in this table confirms that our prototype successfully identified the density difference between the solids, as well as the density difference between water, salt water, and oil. In conclusion, this project demonstrates the Archimedes principle can successfully apply and verify using a low-cost strain gauge prototype. The system is functional, sensitive, and meets the objectives of our study. Thank you for watching.